Let us now discuss the nomenclature of organic compounds. This is our lecture number 3, Organic Chemistry. Discuss rules for naming organic compounds. Also, rules. Number 1. The name of the organic compound consists of 3 parts. They are prefix, word root, and suffix. We have already discussed them in our previous lecture. Prefixes, they are of 2 types, secondary plus primary. Suffixes, they are of 2 types, primary plus secondary. Word root tells us number of carbon atoms. And we have demonstrated it by example. Let us write one name, 3-chloro cyclohex 2-enol. So this is a cycle of 6 carbon now. It is numbered from any end. 3 position is given chloro, 2 position given double bond, 1 position given whole. This is our compound. Now here chloro is the secondary prefix, primary prefix is cyclo, word root is hex, and ene is primary suffix, ol is secondary suffix. This is first rule. Second is lowest number rule. The selected chain is numbered from that end which gives lowest number to the substituted carbon. So this rule states the selected chain is to be numbered from that end which should give the lowest number to the substituted carbon. Let us have a chain of 6 carbons. Here we are having 2-methyl. So this chain is to be numbered from that end which gives lowest number to the first substituent. So this is 6 carbon chain. Carbon number 3 contains 2-methyl, 4 contains 1-methyl. So this is 3,3,4 trimethyl hexane. Then we have third rule. If there are 2 chains of equal length, then chain with maximum branches is taken as the parent chain. If there are 2 chains of equal length, then chain with maximum branches is taken as parent chain. For example, we have this compound. So we have 1, 2, 3, 4, 5 carbon, 1, 2, 3, 6 carbon here. So we'll be adding one more carbon because we want to demonstrate. Now, if we select this chain, then we have the 3 substituent on this, 1, 2 and 3. If I select this chain, then I have 2 substituent. This is one, this is another. So this is our selected chain, and it is to be numbered from that end, which gives lowest number to the substituent. So numbering should be done from this end. This is carbon number 1, this is 2, this is 3, this is 4, 5 and 6. So carbon number 2 and 4 contain ethyl, and 3 carbon contain ethyl, 2 and 4 contain methyl. So it will be named as 3-ethyl 2,4 dimethyl. Then we have hexane. So if there are 2 chains of equal length, then chain with maximum branches is taken as the parent chain. Similarly, we take one more compound here. This is our system. It is having ethyl on upper side. Now to select the longest continuous chain, 1, 2, 3, 4, 5, 6, 7 carbon, 1, 2, 3, 4, 5, 6 carbon, 1, 2, 3, 4, 5, 6 carbon. So the longest chain in this case, which it should contain the 7 carbons. So we'll number it from this side. Carbon number 1, 2, 3, 4, 5, 6, 7. 7 carbon system, and then it has the 2 branches only, 1 and 1 this. If I go from this side, 1, 2, 3, 4, 5, 6, then we have the branches. You write here 7 carbon system. So now 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So these are the 2 chains. If I select this chain, I will be having 1 substituent, 2 substituent. This is a complicated substituent, and then we have no substituent. If I select this chain, then I have 3 substituent, 1 on this carbon. This is a complicated substituent. So I will be taking any one of these 2. So this is 7 carbon system, and this carbon number 1, 4 contains secondary butyl group. So you will be now naming this compound as a 4 secondary butyl, then 3 methyl, heptane, so after doing this rule, chains of equal length, then we have lowest set of locants. Then if you are having 2 or more substituents, number the carbon chain in the parent chain starting from that end, which gives smaller number to the substituted carbon. Now let us take few examples to justify this. So let us first draw few structures, and then we'll name them. Make a chain of 6 carbons. Carbon number 2 and 3, they are having methyl group. We will satisfy the valency of each carbon. Then make the chain of 8 carbons. Carbon number 2 is having methyl group, 6 having methyl group, 7 having methyl group. So how to number these chains? These chains are to be numbered from that end which gives lowest number to the first substituent. In this case we have number 2 from here. So this system will be 1, 2, 3, 4, 5, 6. This is 2, 3 dimethyl hexane. In this system we have octane. Carbon number 2, 3, 4, 5, 6, 7. 2, 3, 7. Trimethyl. Parent chain has 8 carbons, octane. So this is the name of this compound, 2,3,7 trimethyl octane. Then we have another system. We are having the chain of 8 carbons, carbon number 2, 4 and carbon number 7. They are having the substituent. This chain is numbered again from that end, which gives lowest number to the first substituent. So this will be 2, 4, 6 trimethyl octane. Then we have the next system. If there are 2 groups of similar type, 3 groups of similar type, then we use the terms. Rule number 5, use of term di, tri, tetra for 2, 3, 4 similar groups. In case of the complicated group, in case of complex groups, we use bis, tris, tetrakis for 2, 3, 4 similar groups. So if we have a branched alkyl group, then we don't use di, tri, tetra for them. We use bis for 2, tris for 3, tetrakis for the 4 similar groups. Then we have naming of the different substituents at equivalent position. Suppose the selected chain contains 2 alkyl groups. One is methyl, another is ethyl. They are present at equivalent position from both the ends. Then the group which comes alphabetically earlier, it is given preference during the numbering. So let us take a 7 carbon system. Carbon number 3 from both the sides, it is having substituent. 1, 2, 3, 4, 5, 6, 7. Here we are having substituent CH2 3. Here we have CH3. If I number it from this side, that will be wrong, because ethyl is the group which comes alphabetically earlier. So our numbering should be from this end. 1, 2, 3, 4, 5, 6, 7. So this is 7 carbon system, and carbon number 3 contains ethyl, 3 ethyl. Carbon number 4, that 6 carbon, carbon number 5 contains methyl, 5 methyl, and 7 carbon system, it will be heptane. So if the 2 alkyl groups, they are different and they are at equivalent position from both ends, then the group which comes alphabetically earlier, it is given preference during the numbering. Now we come to the naming of complex alkyl substituent. How to name the complex alkyl substituent? If the alkyl group is branched, then how to name this group? In such cases, the numbering of the branched alkyl group is done separately, and it is named, its substituents are also written separately, whose parent will be the side chain. Now let us take such complicated alkyl groups. Now we have a 8 carbon chain, and carbon number 5 is having branched alkyl group. Carbon number 5 is having the group so it will be numbered from both the side. From this side it comes number 4 position, 5, 6, 7, 8 carbon, and this alkyl group is numbered separately 1 dash, 2 dash, 3 dash. Carbon number 1, 2 having methyl group, so now it will be named as 4. Then we write 1, 2 dimethyl. Parent group here is propyl. This bracket is closed. Now we have the outer system, that is octane. So this is the way how to name the complicated alkyl group. Then we have another system. Let us write the structure from the name now. We have 5, 1, 2 dimethyl propyl octane. This is the compound. Then we have 5, 2, 2 dimethyl propyl nonane. 5, 2, 2 dimethyl propyl nonane. So it is 9 carbon system. 3, 4, 5, 6, 7, 8, 9. 5 carbon. It is given propyl, 3 carbon chain, 2, 2 dimethyl. Carbon number 2 is having 2 methyl groups. Now let us complete valency, 4 valency of each carbon. Now this is 5. This is propyl, 2, 2 dimethyl propyl. Then we have 6, 7, 8, 9 nonane. So this is the way how to number and name the branched alkyl groups. Then we have few more names. 5, 1, 2 dimethyl propyl, 5, 2 methyl propyl nonane. So now in this case we are having the 2 branch alkyl group. So if the name comes to you, if you are given with the name and you have to write the structure, you should also practice that. Let us write some names, that is 5, 1, 2 dimethyl propyl. This is one of the substituent. Then we come to another substituent, that is 5, 2 methyl propyl. Nonane. So 5 carbon is having 2 substituent, make the chain of 9 carbon. Carbon number 5, 1, 2, 3, 4, 5, it contains 2 chains, propyl group, 1, 2, 3 propyl, 1, 2, 3 propyl. Now 1, 2 dimethyl, 1 is given methyl, 2 is given dimethyl, given methyl, 2 methyl propyl, 2 is given methyl here. Complete the tetravalency of each carbon. So this is our system. Now this is the structure of this compound. 5,1,2 dimethyl propyl 5,2-methyl propyl nonene. So in this manner we can name different compound. Then we write the structure of one more group. 5,1-methyl 7,2-methyl 5,1-methyl propyl butyl, then 7,2-methyl butyl. Then we have basic skeleton. It is having dodecane, 12 carbons. So make the chain of 12 carbons. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 5,1-methyl. This is carbon number 5. Butyl group is to be drawn from here. 1-methyl. This is methyl. 7,2-methyl. This is carbon number 7. 2-methyl butyl. 4 carbon chain is made here. 2-methyl. Now satisfy the valency of each carbon. Now this is our compound whose structure we have written, whose name was written. Now we have drawn the structure of this compound. So sometimes we are using the tribal names or semi-systematic names. For example, we use isopropyl. Isopropyl is for if 3 carbon group is joined to central atom to the parent chain, but central atom of this 3 carbon is joined to the parent chain. This is joined to parent chain from central carbon. This group is called as isopropyl. Then we have isobutyl group. This is isobutyl. Then we have secondary butyl. Sometime we have used this group. This is secondary butyl. Neopentyl. This carbon joined to the chain. This is tertiary carbon, tertiary butyl. This is tertiary butyl group. If we want to make it neopentyl, this will be like this. This carbon is substituted to the parent chain. This is now neopentyl group. So these are the names where they are used as a prefixes. Then we have tertiary pentyl group. Tertiary carbon is attached to the parent chain. So these are semi-systematic names. They are also used in the naming of the hydrocarbons and their derivatives. Now you try some structure at home. I am dictating some name: 3,3-diethyl 5-isopropyl 4-methyloctane. 3,3-diethyl. You make the chain of 8 carbon. Position number 3 is substituted up and down by methyl group. Then we have by ethyl group. At carbon number 5 you will put this group. This will be joined to the parent chain. And then we have the 4-methyl, 4th position, giving methyl group, and completing the valency of the 8 carbons, you will be getting the name. Then we have 5,1-chloromethyl ethyl. So what we are making, it is a chain of 10 carbon, 8 carbon. So it is 5,1-chloromethyl ethyl 3-isopropyl octane. So make the chain of 8 carbon. From carbon number 5 you will be starting 2 carbon chain. So carbon number 1 is given methyl as well as Cl group, and valencies are satisfied. Then we have the next, that is 3-isopropyl. Carbon number 3 is given this group and completing the valency. So in this manner you have to name these compounds. Tomorrow we will take the naming of the unsaturated compounds. In that case we will be taking the names of the alkenes, then we will be naming alkynes, and then alkenes and alkynes who are having two or more double bonds and triple bond, followed by naming of the compound containing functional group, then multifunctional groups. Thank you very much.